Okay, so this practice question 2 is telling us that we've got to calculate the resistance per metre length of constantan wire of diameter 0.4 millimetres. What length, and then after that we've got to work out what length of constantan would be required to make a resistance of 1.5 ohms. The resistivity of constantan is 47 times 10 to the 8 ohm metres. Okay, let's get on with that then. So, calculate the resistance per metre length. So, to begin with, we're going to say that R is equal to rho L over A, and the length is going to be 1 metre, but we don't know the area, but we do know the diameter. So I know that the area is equal to pi r squared, but from the diameter, that's the radius is half the diameter, so that's going to be half of the diameter all squared. And if I substitute that into my first equation, that will tell me that r is equal to rho times by 1, well, let's put it in anyway, over pi d over 2 all squared. Okay, now let's substitute our numbers into this first part. So we've got the resistivity of 47 times 10 to the minus 8 ohm meters. The length is 1, and we're going to divide that by pi. Let's put it as 3.14 times the diameter is 0.4, but we've got to be careful because we're in millimeters, so let's multiply that by times 10 to the minus 3. Divide that by 2 and square that. Let's just neaten that up a little bit, and we'll put those numbers into the calculator, and that will give us something equal to, and I've got that as coming out as being 3.74 ohms per metre. Okay, now that I know that I've got 3.74 ohms per metre, what I'm now looking for is I've got to get a resistance of 1.5 ohms. So if I know that my resistance is 1.5 ohms and I've got 3.74 ohms per metre, I need to know what fraction is 1.5 of 3.74, and that will give me my answer in meters. So 1.5 divided by 3.74, and that comes out as an answer of being 0.40 meters. Now there's also a little trick with how we do this, because what we can see is if we have a look at the units of this, the 1.5 is measured in ohms, so I've got ohms, and then I'm dividing through by ohms with meters to the minus 1. Well, the ohms are going to cancel, and divided through by meters to the minus 1 gives me just straight meters. So I can look at the units to try and work out what equation, or in order to how to tackle this problem.